Get going. So thank you so much, Gavin Pechey, for doing this spotlight interview. But for the audience that will be watching this, can you give a little bit of background if they're not familiar with you and Sporadicate and your massive ambition that you have? So kind of briefly, what is your big purpose? Who is Gavin Pechey and Sporadicate? What are you trying to do? And I'll go on mute while you share your story.
Thanks, Robert, for having me. It's exciting and it's always fun to talk about what I'm doing. But yeah, it's a big challenge, like you say. I'm trying to solve a bit of the plastic issue by using mycelium and mushrooms to degrade plastic. It's one of the only organisms on the planet that actually can eat plastic and leave no residual microplastics or any other harmful residue. So I think it's a great way of actually having the right solution and not having other issues around recycling. Recycling is a great project. It works well, but the plastics have to be pristine. They can't have certain labels on them. There's a lot of problems and issues that what the plastic has to be in, and anything or any contamination on that, it cannot be recycled. So only about 9% of the plastics in the world are being recycled. And
really, so little?
So little. Yeah. Everyone who puts their plastic into the recycling bin here in the United States thinks that they're doing a great thing. But unfortunately, it's what they call greenwashing. Is you feeling good because you're a greenie and you think you're helping the environment. But in reality, if there's any slightest contamination on that plastic or anything like that, they just send that to the landfill. It's a poor situation. So, and then of course, once you're doing recycling, of course, what does recycling produce? It produces more plastic. So if we're never getting away from the whole plastic cycle, it's just, it's one of those hard components to actually make something out of it. And there are a couple of really nice exciting technologies coming out of it, but ours is one of the ones that actually doesn't have any harmful products or any harmful processes to the environment, which is, I think, pretty key going forward. Now, if you look at what's actually happening on the Earth today, there are 7 billion tons of plastic. Now, plastic hasn't been around for a long time, and I think basically we could call it 50 years. Now, we've already accumulated so much of it, and we're now currently making 354 million tons of plastic a year. So I've done some projections, and some of the research says by the year 2060, we will be making 1 billion tons of plastic a year. So the current recycling processing and percentages, by the time 2060 comes, we will have 4 times more plastic on the planet than we do today. So that's close on 28 billion tons of plastic. Now, recycling doesn't really contribute to the degradation of plastic, so that's not a solution. So I think we've got to come up with innovative ways to get rid of that plastic, because already it's so bad. I mean, the Great Pacific Garbage Patch is the size of Texas. So you can imagine 4 times that in the next 20 or 30 years. So there's got to be a solution for us to work with. So that's our big plan. I think, it would be naive of me to say that I could get rid of all the plastic, but if we can come up with various solutions and make plastic a zero waste product in the next 10 years, that would be as good as it gets.
Can you just two things? One, how did you come to this solution? Your journey, what did you do before that? And secondly, briefly explain how the process works.
Sure. Okay. So I've always been like a business coach, helping small businesses and other businesses grow. And I was at one stage during the pandemic, decided to sign up for school. Business coaching is basically, there's a volunteer system where you can go and volunteer and be a business coach to emerging businesses. Anyone who's got an idea, go along and you can get some free coaching from school. And one of those companies was an exciting banana fiber company that were trying to turn banana waste into textiles. And that led me to Guatemala. And I was on a banana plantation there. And one of the things that I saw was this massive plantations, and they all had this blue plastic outside the fruit as it was growing, and keeping away insects and birds and all that sort of stuff. And I was like, wow, that's a lot of blue plastic out there, and wondered what he was doing about the recycling of that. And unfortunately, it was uneconomic or unviable to actually transport the blue plastic back and forth from the plantation, because it's not an electronic or a engine-based technology. It's humans carrying forward and back and forward bananas. So he actually admitted that unfortunately they carried the blue plastic to the central location. It was then too bulky for them to move it back onto the plantation and cover additional bananas. So unfortunately, they threw it into the river. And when I looked at the size of the plantation, which was 2,000 hectares of banana plants, when you get 1,500 banana plants per acre, by the time you calculated, it was millions of packets a year being tossed into the river. And of course, that was being washed out to the ocean. So I was thinking, wow, that's a pretty big problem. How can we go about solving something about the plastics? And I started researching that. And I met a mycologist, and they said, did I know that fungus and mushrooms degrade plastic? And I absolutely couldn't even, that kind of blew my mind that there was this organism that could eat plastic. So I did a bit of research. And in 2014, Yale did a study that they published around plastic being consumed by an oyster mushroom. And it was taking a certain amount of time, 150 days. And from then on, as I got into that research, University of Colorado, University of Sydney, there's some universities in the Netherlands. Utrecht is a big university around plastic and fungi. And there's really a lot of exciting research going on. And it's all coming up with the same answer. So thought, okay, well, this is a fantastic opportunity to try and commercialize this, because what was happening, it was stuck in the university lab and not coming out into the market. So me being a kind of yes man, I said, yes, let's do this. Let's try and see what we can get. And it's been a really, exciting, sometimes disappointing route. I really like the vision of, helping the planet around plastics. But, unless you do the research and unless you are aware of what is actually happening out there, you've got that greenwashing mentality that recycling is saving us all from our plastics and we're all right. And, sometimes in the United States, there's too much land. So opening up another landfill doesn't seem like a problem as long as it's cheap to get rid of your plastics. And sure, that's it's local mentality without the global outlook and saying, well, what is actually happening on the planet? Does our little landfill create more problems, and how long will that plastic in that landfill take to degrade? So, I mean, it's very communal sort of thinking, and it's much cheaper to drop off your plastics into the landfill, and a bit more expensive to send it to recycling. So they're making these economic decisions. But if you look at landfills, I've seen like telephone books from the 1920s, 1900s that are in the landfill, and they've seen no degradation for 100 years. That's just paper. That's what you would think would be easy for it to degrade. So you can imagine what a plastic item will look like in 100 years. No degradation. 200 years, no degradation. This is stuff that's built to last. So really, there has to be another solution. And that's kind of where it starts. So, I think as we get the movement going and more people interested, that sort of community will start turning to their city and saying, well, I don't think recycling is working, or I don't think the landfill's working. We want to see degradation of plastics in a complete cycle. And I think that'll be our biggest win in the future. So
you take mycelium, you throw it onto plastic. I guess you make a kind of mix, maybe with some water or something, and you just leave it alone for 100 days.
Yes. So basically, it's like a little bunker, and our current concept is around 53-foot containers where it has you can convert the top to a lid. Basically, you would put a substrate in there, which is your basic growing medium for mycelium, with wood chips. You can even use cardboard if they're in there. You can use straw and various types of substrate. You would then mix in the shredded plastic. It's got to be shredded. I can't be throwing plastic bottles into that situation because, of course, the volume is too much. So I have to take plastic and I have to melt it into a semi-liquid form and then shred it. So you keep on getting small ribbons of maybe 1 centimeter by 0.5 centimeter. And then I would introduce that into the bunker. You would then seed that with mycelium spores and basically give it conditions that is warm enough, there's enough moisture, and there's no competition from other mold or other fungus around to make sure that it can thrive in that situation. So the mycelium will then start to grow. It'll start to spread in your bunker. And then eventually what you really need to do is you need to starve that mycelium. So, mycelium mushrooms, as you can use and eat wood from the forest. And those are the very similar types. Well, those are the types of mushrooms that we're using in the plastic. They're eating the carbon out of the wood, out of the trees that have fallen over. And that's how they survive, how they degrade the fallen trees, and it becomes this organic compost in the forest, and then revitalizes the soil to allow more trees to grow. So that's basically what's happening. Is it's that same fungus that is then turning to the plastic as a food source, because plastic is a carbon molecule. So what you really have to do is starve that poor mushroom to a certain stage that'll turn to not the easiest food source, but it's quite a hard food source to break down the molecules, and it turns to the plastic and then consumes those carbon molecules out of that. So that's where the big win is that there are no microplastics, because once you start consuming the carbon molecule, there's no residuals. The only residual will be this organic compost that you see on a forest floor. And then that's something that we can use in agriculture by putting it back onto the land. And that would facilitate better crop growing, more additional nutrients for the soil, because it's high value compost with this mycelium in it. So it's a big cycle, and eventually what we really want to look at is there's so much research going on in Europe at the moment, and I'm pretty excited to start looking into that. But at the moment, you've got to focus on the degradation, but eventually some of the side products that can come out of the mycelium I've seen as mushroom leather, mushroom packaging, mushroom furniture. There's mushroom sheetrock for construction. So there's so many new products that are coming out that mycelium is creating. And I think eventually that's something that we would want to look at, is to complete the cycle of saying, well, one day this one was your plastic product, plastic bottle, and now you're sitting on a completely natural mycelium chair, or you've got this nice leather coming out of this mycelium. And this whole circularity of the economy has been a big focus in the last couple of years, and I think we could be one of the ideal candidates to actually have a success story about it.
How much, if you said it's about 100 or 120 days to break down plastic bottles and other plastic, and it doesn't matter what type of plastic it is, you can just mix it all together. So what do you get after 100 or 120 days?
So the only plastic we can't do is PVC, because of the chloride in that just kills the mycelium. So that is one that we would have to continue sending to the landfill, finding another disposal way. But so out of the 120 days, some of it can extend to some of the more difficult plastics to 150 days, is you get this organic compost. So it's just that substrate and the mycelium, where they'll be inside the tank. So there's no plastic residue. It's just this ideal growing mechanism for the mycelium. So once you dump that out, that compost is so reasonably clean, well, so clean that you can put it onto fields, use it maybe as fish food, land, livestock meal, anything like that. There's a kind of lot of ideas about how we can actually maximize the mycelium out of that bunker, because mycelium is 40 to 49% protein anyway. As you would know, when you eat your mushrooms, they're really a great protein source. So that same protein source can go to fish, can go to animals, livestock, and basically become this food and or compost for the land.
But the so do you have like this? You put them in containers, kind of shipping containers to.
That's it. That's that for me, I think, is the best vehicle for the degradation, because it allows us to open up the top, dump all the plastics and substrates into it, and then once it's all done, open up the side, and then you'll be able to clear out that container of all the organic compost, make sure all the plastic's being degraded, and then just verify that everything's where it should be.
And can you reuse the mycelium in that mix, or you just dump everything into the soil?
Currently, it'll be dumping everything and restarting again.
So each time you have to grow mycelium, I guess.
Yeah. And it's pretty easy. Comes in a liquid form with spores in it, and it's easier to inoculate. And some of the mycelium are very aggressive and they grow very quickly. So, that's kind of the next thing that we want to look at, is once we've got our commercial opportunity, some of the research that we're doing in the background is how can we manipulate certain characteristics of the different mycelium to formalize one hybrid mycelium, where it would be hungry, a quick grower, well, very aggressive, one that doesn't really affect the climate outside, is it's not as affected as some of the other species, and basically can break down the plastic compounds quickly. So that's kind of the next stage of our research. And once we do that, you'll see the 120 days get cut down to maybe 80 days. And then the next step would be, okay, once that's done and we have the right hybrid mushroom, we would then extract the enzyme that actually breaks down the chemical bonds. So what would happen is once it comes out of the shredder, you would then introduce it to the enzyme. The enzyme would then basically start breaking down the compounds of the carbon compounds, and it would be easier for the mycelium to consume. Once we do that, then your turnaround from 120 days, we're seeing, well, we're hoping that that would be reduced to around 60 days. So quite a huge saving in time.
Wow, wow.
Once you've done that, so your volume of plastics that you degrade every month would increase significantly, basically double, and we would be able to be in a better situation. But it's about a year or two out on that research, and I think, you know, as we go along, we start off with a slow but steady method, and, you know, learn as we grow. And this is kind of where, you know, getting a city like Pocatello in Idaho, it's, you know, not a large creator of plastic waste a month. They do 20 tons, and they are prepared to wait for it. They're prepared to, you know, support us. They've given us land. They've given us access to water and electricity. So basically all I have to do is dump down my containers. They'll provide the plastics to me on a weekly basis, and we would go through it, you know, in a staged process. So they prepared to be patient. They understand the situation, and I think that's kind of key to our success, is not rushing around and telling everyone we've got this huge solution until we're ready to roll it out to that next city. Once we've got that.
The residue, what's left, there's no oil?
No oil.
So it's just like an organic, it's like
pretty
wood
much
mass?
What you would see is forest on the bottom of the forest, is that, you know, like kind of wood chips. That's pretty much what's left over. So
does it have a high nutritional value for the soil, that you can restore the health of the soil?
Absolutely. So I mean, yeah, that's why forests and everything have got great ecology. The mycelium have broken down those trees to provide this additional organic compost to the forest floor. So it makes the forest thrive, basically does everything in your complete circle, that we'll be taking that same system and putting it out and using that as plastic, but the results are exactly the same.
And you also mentioned to me a while ago that you can recycle, you can break down plastic at like a kind of recycling center or kind of the garbage disposal center, but that you're also looking at using mycelium on super sites, these massive thousands and thousands of hectares of toxic soil. How does that work?
That's a really exciting process at the moment, that we're working on 2 Superfund sites, one in Butte, Montana, which is the largest Superfund site in the United States, 54,000 acres. And really a lot of copper mining that was done there over 100, 150 years has left that soil extremely contaminated. And basically what we do with what you have to do it as a seed stage is introduce the mycelium to a seed of a native species of tree, of the location that you'd be working in. Then that symbiotic relationship between the seed and the mycelium form starts to grow. And as that seedling starts growing, so out of the root structure of your tree, you'll see extended hairs coming out of that. And that's your mycelium growing out of the root of the tree. Now those become like superconductors of contaminates in your soil. and they absorb all the minerals out of that soil and introduce it into the tree. So your tree becomes your storage unit. So, I mean, we've looked at heavy metals and that's range of copper, lead, iron, that all gets absorbed, even items like arsenic, that's contaminated water, that gets sucked up into your tree. And basically your tree is your hard drive, your storage unit for the next 100 years, depending on what sort of tree you use. So Montana, we're using different types of firs, Doug firs, and that will live and clean that soil for the next 100 years. So it's not a quick process, but it's environmentally friendly process, and it's achieves actually the absorption of all the contaminants. Now, current technology around cleaning a Superfund site is removing the first yard of soil out of an acre plot, and then spread that same soil over, say, 10 acres of land. So your 20% contamination of that land would then reduce to 2% on the other land. So basically, you're spreading the problem, but the problem doesn't go away. It's still there. So our trees then absorb all those chemicals, reducing it to its original state of the soil, and basically allowing other plants to come in and thrive. So I think, whilst we say that the time is long time, it's indeed possibly the cleanest way. And then, after 100 years, we then have to harvest those trees. We won't be able to burn the trees because then you're burning the contaminants back into the air, but you'd be able to make different products out of your trees. And I think that's where the kind of community solution comes into. If you work with a city or you work with a community around that, and you build a whole bunch of trees grow trees, then you can actually use that lumber to make boardwalks, different, wood buildings, and all that sort of stuff. So it goes back into the community. And as long as it's sealed in the right way, those trees will then provide different aspects and back into your community. And you will still say, well, those are the trees that actually clean the land, so we're in a better position. So I think that's an exciting concept. A lot of people are interested in that, and as we grow, you'll see that extends into not just contaminated heavy metals, it goes into oil. So there's oil metals. Your trees will then clean that, and then basically a lot of other contaminants, including fertilizer. Because one of the things that was surprising to me was retail fertilizer stores have got large contaminated land because they keep on unloading and offloading this fertilizer, and it's every now and again a packet breaks, and all that fertilizer falls into the same area. So it becomes high in phosphates, high in nitrates, high in all these other chemicals, and then that starts killing off different growth fauna around it, and then it gets into the waterway, and then that gets into your rivers, which create large algae blooms. So there's this whole cycle of problems. Now with the trees that we've got, that'll actually clean those phosphates out, clean those nitrates, clean those additional chemicals, absorb it into the tree. That allows you to clean the waterways, it cleans the air, and it cleans the soil at the same time. So it's this multidisciplinary cleaning environmental remediation method. And I think, as we move on, so you'll find that, nature is always the best healer of nature. It always strikes me as a bit surprising, is whenever you see these like dystopian movies, if they removed people from the planet, what would it look like? And you will see that after a while, vegetation starts breaking down, building starts breaking down, everything that man put, and vegetation takes over the planet again. And that's exactly what we're saying. Vegetation and trees and these various methods create that opportunity for nature to actually, regain the upper hand on some of the contaminated sites that we find ourselves at in the moment.
But the budget, I would imagine, for cleaning up these super sites are monumental. I mean, because they're so big and it takes so long to clean it. It's not like, 100 days or 120 days. So it's a very long process, which means they would need to engage you for a long period of time, I would imagine.
That's yeah, that's a good sort of like methodology of doing it. You can't just rush out and then plant a million trees tomorrow, but it would take a 5 to 10 to 20 year look at it, where you have structured growth patterns and um, the best methodology of planting. You'll find that those will be a 20-year contract, but it's much cheaper to grow trees than to remove the soil and spread it over some other land. So sure, the cost, the timing is longer, but the cost is much cheaper, and the actual total efficiency is much greater using trees. So,
have you started on a portion of the land at Butte, Montana?
yes, we've planted a few test subjects there, and they've survived the cold winter of Butte already, and that's a great start. Once, because you plant surprisingly in fall in Butte, and then the snow will come and it'll hibernate your little seedling for the first, say, 6 months, and then as soon as summer comes along and it starts melting that snow, so that'll irrigate the water and allow your seedling to thrive. And that's kind of the stage that we're at. Now, I haven't reinvented the wheel yet. This mycelium-infused trees has naturally occurred in nature for hundreds and thousands of years. Just that it doesn't happen to every tree, and it doesn't happen all the time and in certain areas. It happens in a very haphazard way, where one of a million trees basically forms a symbiotic relationship. And once it does, those are the trees that really thrive and generate good growing conditions for the other trees. So it's not new technology. It's just finding that the right technology has got the right solutions at the current moment.
So, but I would imagine with these two business opportunities of eliminating or breaking down plastic for recycling centers, do you sell that as a service? Is that the business model? Or do you sell the machines with the mycelium and they do it themselves?
Currently, we're selling it as a service. We've got to prove to everyone that we can do it. We can move into different areas and different cities and replicate what we started at Pocatello. So that's kind of how it is. But I do see the future is partnering up with other waste management companies that are interested in the solution, who have got the land already, and they can just convert a bit of their land into a mycelium bunker site. And we could then, supply them with the mycelium, supply them with supplies that they require, and make sure that anyone who's interested in doing this can do it themselves. So even goes down to the individual person. In say 10 years time, you'll be able to go to a store and buy a mushroom pack and say, okay, you've got your little composting area in the back of your yard. You can introduce these mycelium and then basically put in a bit of shredded plastic, cut it up and start degrading it on a personal basis. That'll really give you that idea.
Yeah, but was it difficult and challenging to get, whether it's Butte, Montana, which is a big project, or Pocatello, a recycling, to convince them that don't buy an incinerator or don't, do the traditional way. Here is a way of using nature to clean up the mess. Did they believe it?
Butte does grow normal, is using a tree phytoremediation already. So basically, they're using trees to do this. So they are aware of the results. They, this mycelium ectomycorrhizal infused trees is a new sort of avenue for them, and they're ready to use that experiment. But the actual whole solution around trees has been around for a while to remediate some of the land. So it's just a slight upgrade on that. So it is a bit difficult, and you have to provide the science and the solutions to them, and it takes a while. And then, of course, strange enough, Pocatello was really eager right from the start. They were, their recycling rates are 70 to 80% within the community. So the community is really recycled focused. And when I gave them that solution, they were like, "Oh, this is exciting. This really fits in with their agenda. The community is really focused on it." So it wasn't a big push for them. But the problem is it takes time for government to move. So it's, you get the buy-in from the mayor right away, and some of the city council was involved. And then, okay, well, how do we allocate the land?
It froze. I think it'll come back in a second.
Your
okay. Camera froze.
Are we back?
Yeah, we're back. Yeah, you're back. Yeah.
Sorry about that. Stuck in a hotel. So the thing about, I don't know where we left off, is Pocatello.
Long-term relationship between Pocatello and Butte.
Yeah, it takes a while for government to move. So, they allocated us some land, but they've got to do certain things before they can actually give you the land. So that process takes a while, and that's been kind of a year in the waiting. Butte also has been a year in the waiting, introducing ourselves, them deciding where's the growing patterns, what areas can they use us for, and then basically that's also been a year and a half of waiting for those opportunities to come around. But it'll be, I've always suspect that everything that's worthwhile doing takes a while before it, gets accepted into as a new technology or a new way. And then once it does, implementation of that happens very quickly. So once we prove it out in Pocatello and we're doing their recycling, basically the next 20 cities will be a small conversation. The next big city will be a big conversation, but it'll happen a lot faster than our initial idea.
Yeah, once you can show that you can deliver. I had a crazy idea. I don't know if you've ever watched the TV show The Last of Us.
Absolutely.
So why don't you get them to support your project and use it as an example of the positive example of all of these mycelium creatures that are in their show, and adopt it, Sporadicate there. I mean, they've made a lot of money on the show, and they're coming out. There's now a season 2 coming out. I don't have connections in the Hollywood scene for that. But maybe if you write the creator, maybe you think, hey, that's a cool idea.
Absolutely. And I mean, when I try and when people are interested in hearing about what mushrooms and mycelium are, that's a great example. And they ask, what is mycelium? And I say, well, if you watch the program, you'll see that there's these huge mycelium like fields, and they've got all these like little growing networks. And no matter whether you just have to touch one of the networks, and something way 200-300 meters or 3 miles away actually realizes that there's movement here, and it'll send those people to where the people to where the movement is. So it's that whole network, and it's a great example of how to demonstrate what mycelium and how effective mycelium is. And it's this huge organism that is there to create and distribute networks of contamination, food and organic products. So I think I've definitely referred to The Last of Us many times. The whole craziness about them being zombies is another story.
Yeah, well, I have a friend who's kind of a Hollywood producer, and he's well connected, and his son works for Apple TV or Apple. I'm going to speak to him tomorrow, ask him if he does have any good contact with the producers of Last of Us. Maybe and he's active in nature-based solutions. So we'll see what happened. They have nothing really to lose. And where would you like to take Sporadicate because it can grow really fast, like a mushroom, uh, and you can scale. There's not, massive. You don't have to build petrochemical plants, so it's relatively, I guess, it's relatively low tech. The containers to build, to order that. And then it's just a question of scaling up the production of mycelium because there's plenty of plastic. There's no shortage of plastic. Did you ever speak to any of the big beverage companies about this?
That is kind of on my agenda, but I haven't yet because it's that cat and mouse game.
Yeah.
I'm not in a situation to demonstrate exactly the level of scale at the moment.
Yeah.
So I want to go then with a full solution that's it's got data to show that this is actually happening. And once I get that, I think those will be great partnerships. I've also thought about oil companies and plastic manufacturing companies. Those would be great partners because no matter what, plastics is here to stay because it's just such a great product. I'm not ever saying that plastic is not a good product. It's a great product. It's cheap, as a container. It keeps all your food and vegetables fresh. And there's no way we could ever replicate that on a scale that plastics does. I've heard of a lot of new plastic alternatives. I see the benefit of those, but I don't see them ever being able to produce the 354 million tons of plastic they're producing every year.
Right.
So, I think plastic has to be in our future. We just got to make sure that the plastic that we use in the future is easy to decompose and come up with different solutions to how we can actually structure that so we can actually get to a situation where there's zero waste. Because I think that's kind of goal in the future. It's like, not much I can do about the 7 billion tons on the planet at the moment. But if we got to a stage in, say, 10 years' time, that if we produce 4 million tons of plastic a year, we can degrade 354 million tons of plastic a year. So then, it gives us that, zero gain on plastics. Infusion.
So you want to take this to a very large scale with the right funding. Absolutely.
I mean, it's like the idea now is I'm currently in San Francisco today. If we came.
Oh yeah, that event I told you. Yeah.
So if we came to San Francisco, there's no way I could say, okay, I'm going to have one plant here for all the plastic remediation of San Francisco. There's just too much. So I would say that I would set up at least 5 to 10 processing units around the city. So the distribution of plastics and recycling can go to a local site without too much transportation costs. and then those little areas then degrade the plastics in a local community rather than
Right. Yeah. Well, that's a good idea.
yeah. And I think that's the way we're going to get around it. One big site would be just too cumbersome for us to transport all the plastics and everything like that. But these small, agile little processing units would be achievable. So that's kind of how I expect to scale it out. And I think, getting the right partners at the right time, that'll be key.
One invention, or a friend of mine told me about this company that developed a simple machine which looks basically like an espresso machine. So it makes, espresso, cappuccino, but they've built on that, and you can make beer, you can make Coca-Cola, you can make soda water, any beverage with a capsule. So, and you just attach it to your water line, and you don't have to schlep all those bottles and plastic. You don't need them. And
That's
if you do that on a big scale, you don't, all that area at supermarket for plastic bottles, if people have this at home, you won't need it. And I tried it because, yeah, sure. I mean, I like coffee. The coffee was okay, but it wasn't really, Italian espresso cappuccino, but it was like most of the other machine coffees. And then they made a beer for me. I prefer Belgian beer, but it was a Pils, and it tasted like a Heineken. And then they made a Coca-Cola cola additive, and it was amazing that it works, and just with a simple capsule you can recycle, and you can reduce 50 to 70% CO2 emissions from the beverage industry, and you don't have to move all that plastic. So maybe between you cleaning up what's already there and maybe this reducing the flow will make some headway in this. Um, and what specifically drew you to joining the circle, the TBLI circle? Because I'm always curious. Various people join for different reasons. You're not 20 anymore, so it's not about your career. What was specifically that you felt interested about being a member there?
um, well, as you can tell from the accent, I'm not exactly from the United States. I was born and bred in Zimbabwe, and then moved to South Africa at university stage. Stayed in South Africa for many years. Then I moved to Canada. Stayed in Canada for 8 years, I think, and then moved down to the United States basically in 2017. So I've been an adventurer most of my life, I would say, and it has left me with certain holes, and that mainly is a network and
Mm,
finding people that I can relate to within a community. So uh, that was kind of, a big issue for me to find all these, got these big plans, and now I don't have the support of people or a network or anything like that that I can draw on. So when I looked at the community and the circle, I mean, that just highlights they like-minded people. So
yeah.
they're interested in the environment, they're interested in in technology, and they're looking for opportunities. And even if they don't, they're ready to support new projects. And that's kind of what I needed at the stage, because it's all
Right.
fine to be doing it by yourself for the first year or two. You can get through
Yeah, right, sure.
a lot of the work and make the right sort of introductions. But after a while, your capacity uh, diminishes. It's just there's only so many things that you can do. So one of the things was just don't know anyone with investment contacts, and you basically have been my savior with that sort of
Oh,
support.
we still need to get that check. That's
I
it's
know, but I
it
know
will
it's
it will come. It's just that I just wrote an article about the lack of impact investors that will support startup companies or that will support emerging managers. They all want basically gold that fell off the truck and is brought in the living room. So it remains a challenge, and particularly with uncertain sector. So, I mean, we'll get there. It's just the process is toilet cleaning. It's not fun to do, but you have to do it kind of every day. And I still have a good feeling about Honeycomb and Raise Green, that crowdfunding group. I mean, you've spoken to them?
Yes,
Yeah.
yes.
Yeah.
I will action that in the next couple of weeks.
Yeah, I mean, they have a process, but they have a 90% success rate.
That's
Very
it.
high success rate. But what's interesting is I met I spoke to the CEO of the company at the top,
Oh, okay.
and his name is George Cook. And I don't know if you ever saw a movie that's always shown during Christmas, It's a Wonderful Life.
Of course.
So George Cook is George Bailey.
Oh, wow.
His family started in Appalachia 150 years ago, a community bank only lending money to, the butcher, the baker, the candlestick maker. And that led him to create that crowdfunding. So I was like, wow, a real community banker with 150 years and in an area that's not Silicon Valley, Appalachia. And that his so it is he's a good guy and a good organization, but they're very careful as with their due diligence. How can the circle members that are going to be listening to this help you?
I mean, like I said, it's that community-driven project. I mean, start talking to people about what we're doing. And then the more people we know and the more support we can drum up is, the greater start. Um, you know, as we're moving along, so money becomes a bit of an issue, but, it's not going to stop us. I've got good feelings about the future. And
I do too. I do too.
yeah,
You're in the right space, and we're finding more and more interesting organizations that are willing to do early stage startups. I just met another one who was very focused on ocean out of Connecticut. And then I said, we do, pre-seed, super early stage. So I said, okay, well, we'll send you something your way. So I'm quite confident about it. But the ones that are doing the most talk the least, and the ones doing the least talk the most. So we have to filter out the noisemakers. And and I hope that you meet in San Francisco very civilized, non-extractive people, which makes up most of the members of the circle I would say are not focused on extraction,
yeah,
much
it's
more about collaboration.
I mean, yesterday's event was around climate tech and
Mhm.
sustainability. But when it came down to the nuts and bolts about it, people were talking more about batteries, nuclear energy, all that sort of stuff. Because those are the cunning, the main problems, and we're going to be facing in the next 10 to 20 years. Is how do we charge those electric cars? How do we build the batteries for them? How do we generate all this electricity for these data centers? How are we going to make this all happen? And I mean, basically a lot of the focus was, okay, nuclear is there, this different type of batteries there and everything like that. And there was like these good opportunities coming out of it. And that's how it was. And, how does AI help with this? And I mean, even some of the responses to the nuclear uh, nuclear powers was, we're not using AI yet because it's a supportive nature, but nuclear is just developing the new small modular reactors and new technology, but AI hasn't come into that area yet. But they were looking for it to come in at some point. So there's a lot of focus around that, but no one's wondering, okay, well, sure, we're extracting all this lithium or we're extracting all this stuff from the earth. Who's actually going to remediate that land once we've done it? And no one was talking about that. And that kind of left a bit of frustration to me because I didn't want to stand up there and say, sure, I hear what you're saying, we need electricity, but what does it do to the planet? How are you extracting all these different types of chemicals, rare earth metals and all this, and yet you're just discarding the mines after a certain
time? Most of them are just unicorn chasers, pretending to be climate heroes. They're all driven by the 10X, and they're not concerned about the mess left behind. That's somebody else. We're not going to make money on that, so why should we bother? So it's once we extract what we need, we do the IPO, we exit, and we make our 10X or whatever returns for our LPs and move on to the next extraction.
Exactly.
So that's pretty much how it is with many. There are some examples that are doing things, but it is a challenging, once you get to the first 5 million, it becomes easier. Not easy, but it becomes easier. So your threshold is still quite low. So I'm quite sure that we'll get there. I'm quite sure that we'll get there, and we will be able to do a ribbon cutting ceremony with you.
Honestly, some of the contacts that you gave me, Mauro Andretti, has been really amazing. He's worked and continues to work with me around fundraising and some of the Italian funds and the EU funds and all that sort of stuff. And we finally submitted.
There's a lot of money within the EIC and various, and particularly one of the few that will fund early stage startups.
That's it. So we've submitted our proposal to the EIC. We're waiting back for the next 30 days to see what's going on and how quickly we can manage, well, what the interest levels are. And then we have the Italian fund, should know in about 30 days with that. And that'll give us our base to jumpstart where we need. And I mean,
I think I told you that the guy from Anglo American wanted some information, so I sent them some information. And it was Easter, so I left him alone, but we will chase him down to find out if he wants to have a conversation. I mean, obviously, they're talking of like super sites, that's exactly. They're very big.
And I mean, I've got the right people for that. So it's just, it's just getting the right situation, and we'll be able to implement that process quite quickly. So there's a lot of work that's been done in the background, and we're just ready to jump in and get going. So all these contacts have been amazing.
So let's put out also this ask for, if you're an investor and seeing this and want to learn more, contact Gavin at Sporadicate. If you have good contacts among the European academic community, particularly in the food technology and agricultural technology, and are willing to help Gavin make an introduction to the university. I've not been able to get anywhere with Wageningen. I just don't have the right contact there. So anybody who's listening who does have that, please contact Gavin and make that introduction. Gavin, it's been a joy. Thank you so much for this conversation, but also for what you're doing, because I know it's very, very heavy lifting. It's not easy. And, we're not 20 anymore.
Unfortunately. But I really appreciate your support, Robert.
My pleasure. This will be, we're going to do two things. We're going to post on the weekly, and then I'm going to have Sam post, we're going to post it on the Circle this evening, and then I'm going to have Sam post it in the weekly that goes to about 55,000 readers next week, so that it'll reach a large group, and we'll get there. It's farming, not hunting.
Absolutely. Absolutely.
Gavin, thank you so much.
I appreciate it, Robert. Thank you. Okay.
Stay well.
See you soon. Okay. Bye.
Bye-bye.